Okay, so last time around we finished the qualitative research, the sampling techniques actually. So there was non-probability sampling techniques, there were probability sampling techniques. Now we will come back to the quantitative data analysis. So this is an important thing which you should know. And first of all, you must remember this concept. The concept is, see the slide which I have shared with you right now. You can see that population, if you can calculate the mean, median, mode, like the average or the range or standard deviation or variance of the population, you will call them parameters. So population has parameters. I know it is difficult in many cases to calculate the parameters. For example, let's say you have a topic of impact of promotions on customers in Oman. Now would be millions of customers in Oman. So can you calculate the mean, median, mode for the whole population? No, maybe no. This is not possible. So parameters, sometimes to estimate the parameters, it is difficult. So that is why when we have a sample with us, we try to calculate the statistics. Statistics means mean, median, mode, or standard deviation or range for the sample, not for the whole population. This is the concept of statistics here in research. This is the technical thing which you should know. That means you need to calculate many statistics for the sample. Now, your statistics. Now, you must know parameter is a word which is used for population. That means if you can calculate the mean, median, mode, or standard deviation or variance for the population, then you will call them parameters. But if you cannot do that, of course, most of the cases we cannot do that, we will calculate the mean, median, mode. These are the averages, right? If you could remember. For the sample, we call them statistics. Now, statistics can be of two types. Okay, see the slide which I am showing you right now. Statistics can be descriptive statistics or inferential statistics. So the first one is the descriptive statistics. What are descriptive statistics? Descriptive statistics are like mean, median, mode, or standard deviation, or variance, or range, things like that. Why they are called descriptive statistics? See, let me take an example. See the slide right now. Let's say this is the average age of some school class or 12th grade, let's say, or 10th grade class. Now, how can I tell about it? So the mean is 15 years. That means the average age in that class is 15 years. Median is 16. That means median, what was the median? That means the middle age in that class is 16 years. Mode, remember, mode means the most repeated value. In this case, I will say the most common age. The common age in that class is 16 years. That means most of the students, they have 16 years, they are of 16 years of age. The minimum age is 8 years and the maximum age in that class is 20 years. What I am doing? I am just describing the statistics. These are statistics from the sample, let's say. So I am just describing these statistics. There is no result. There is no comparison. Such type of statistics are called descriptive statistics. Okay, you can make graphs for them like bar chart or histogram as well. You have done that before. So let me take one example as well for that. See the slide. This is the marks distribution of the students in the class out of 20. So how many students got how many marks? And what is the percentage of students who got that marks? See, the first one, on your y-axis, you have the marks. Blue bar will tell you number of students, how many number of students have taken that marks, and the brown bar will tell you about the percent, how much that student percentage is there in that class, how many of them is there in terms of percentage. Okay, so 8 marks. How many students got 8 marks? One student got 8 marks, and the percentage is 3.2 in the whole class. That means out of 100% students, 3.2% students, they got 8 marks. That means one student. How many students got 9 marks? 2 students got 9 marks, and this is 6.5%. That means out of 100% students, 6.5% students, they got 9 marks, or 2 students got 9 marks. Similarly, how many students got 16 marks? 5 students got 16 marks. What is the percentage out of 100? 16% of the students out of 100% students, they got 5 marks. Similarly, how many students got 20 marks? If I ask you, 2 students got 20 marks. What is the percentage of those students in that class? 6.5% students in that class, they got 20 marks. What I am doing, I am just describing the statistics. Such type of statistics would be called descriptive statistics. They are not telling you any result. They are just describing your outcomes, or if you see how many marks you got, what do you think? What is this? This is demographics. This is a factual thing. What is your age? This is a demographic. What is your income? What do you do? What these type of things are demographics. So demographics are mostly described by descriptive statistics like mean, median, mode, or range, or graphs. So descriptive statistics are just for describing the sample characteristics. Do you get my point? That what are descriptive statistics? Statistics mean these are related to sample. Statistics mean these are related to sample, and statistics are of 2 types. The first type is descriptive statistics. Descriptive means they just describe the sample characteristics and they do not test anything. They do not test anything. Okay, now I put up, let's say we have a research topic which is issues of caste to students. Issues of caste to students. Now, let me ask you, let's say I make this hypothesis. This is the hypothesis which I want to ask from you, that what should we do with it? Or how can we check this hypothesis or test this hypothesis? Okay, the hypothesis is the CGPA of female students is significantly higher. This is the hypothesis. Hypothesis means that this statement is coming from your research questions and research problem, right? So this is a very important statement which you need to test. This is the contribution of your research. So you are saying that the CGPA of female students is significantly higher than male students in CAS Sur. Now tell me, how can I test this? Just think carefully about this hypothesis. What do you think? This is the hypothesis which you want to test. Hypothesis is a statement which you want to test. Hypothesis comes from your problem statement, research questions, or research objectives. And this is a specific statement which you will test, and this will tell the contribution of your research. So the topic was issues of caste for students. In that, you made one hypothesis. The hypothesis was that CGPA of female students is more than male students. Okay. So first of all, you would have some sample with you, right? Okay. So my sample is that female students are I will make a questionnaire, right? You will make a questionnaire for issues of caste or students, and in that questionnaire, you will ask a question: what is the CGPA? What is your CGPA? Now, this is a factual question. This is a fact. What is your CGPA? Is your fact. This is not your opinion, or this is not something from for which you will strongly agree or disagree, right? This is a factual question, and I will make it open-ended. Open-ended means I will put a blank, so you will put your CGPA in it. Okay, in that questionnaire. Let's say in my questionnaire is filled by 200 female students. Total sample size is, let's say, 250, and male students are 50. First of all, tell me, is it okay? So I am conducting a research. In that research, I have this hypothesis. Hypothesis is coming from my and of course, I will collect the data through some questionnaire. So questionnaire was distributed to 250 students. 250 out of 250 female students are 200, male students are 50. First of all, tell me, is this sample okay? Very good, Mohammed Saeed. You actually answered it. I told you the rule of 30. I told you the rule of 30. Rule of 30 means your important demographics, in your important demographics for your research, the sample size should be at least 30. This is a rule of statistics. This is not my rule. There was a person named Koshram, statistician. He gave that rule in 1960. He is still alive. He gave that rule, which is widely accepted. What does it mean? That in my sample, if male students are more than 30, it's okay. You can test it statistically. So more than 30 is there in terms of male students. So male students are 50. Someone can say that 200 females and 50 males, maybe there is some issue. No, there will be no issue as per statistics. Why? Because male students are more than 30, which is fine. Similarly, for this research, another important demographic is, let's say, your year of study, whether you are in foundation years, whether you are in year 1, year 2, year 3, or year 4. I will make sure, let's say I am doing non-probability sampling. Most of the time you will be doing non-probability sampling like convenience sampling or judgmental sampling. That means the purposive sampling. You will make sure that every year of study has at least 30 respondents or sample in it. At least 30 should be there. That means your sample is okay. Now tell me, what should I do? So the sample is okay as per Mohammed Saeed, and it's okay as per the argument or the evidence which he has provided. That's fine. Okay. So now what should I do? How can I test? What do you think? How can I test this hypothesis? The CGPA of female students is significantly higher than male students in CAS. So, or what do you think? What should I do? How can I test this hypothesis? Whether this hypothesis is true or false. I'm just asking your idea. Whatever idea comes to your mind, you can just tell me. Yeah, Samasai, you are writing the same hypothesis in the same in different words. Uh, if I have to make a hypothesis, I will not put no in it. Okay, because when you are doing research, you should always make, this is a norm. I told you before, maybe as well. In your hypothesis, do not put no. Put it like this: there is significant difference between female and male students CGPA in CAS. Always make hypothesis of affirmative sense. Affirmative means do not put no in it. So either that will be true or whether it will be false. Okay. So this is a norm. Norm means in many research papers, now you would have read some research papers, alhamdulillah, you will see they will never put no in the hypothesis which you are presenting. Don't put no. Sama said, so how would you test it? How would you test it? How would you check whether there is significant difference between male and female student, or there is no significant difference between male and female student? Your hypothesis is okay, but the better way to write is you should write there is significant difference. Do not write no. Either that statement will be true or false. That is hypothesis, right? So, but the norm means the practice of many people or researchers is that they do not write hypothesis with no. You have written it right, but the practice is do not put no in the hypothesis. So, how will you test it? This is my question to all of you. How can I check that the CGPA of male students or female students is different, or it is not different? How can I check? Just anything which comes to your mind. Marks. Okay. In my questionnaire, yeah, in survey questionnaire, you have asked what is your CGPA. So what will I do? I will get 250 questionnaires. In those 250 questionnaires, I will separate male and female students questionnaires. Then I will take the average of female students CGPA, and let's say the female student CGPA is average, female average CGPA is 2.5. Okay, and for male students, sorry, male students, I'm taking an example in which I will, yeah, study for their grades. Yeah, CGPA, what they have mentioned, I will, the average for the female students is 2.5. I will take the average, right? You know how to take the average, mean. And I will take the male student average. Software will do it directly, like SPSS will do it directly. I'm just taking an example. So male students is 2.3. Okay, this is what I get from the questionnaire. What do you think? My hypothesis is true or false? Can I say based on comparing the CGPA of female students and the mean or average of male students? My hypothesis is true or false? Do you think, is this the right way? So you are saying my hypothesis is true. Others, true. Okay, true. Now here comes the catch. Yeah, here comes the catch. We all think this is true, but I made one statement before. The statement is you cannot use descriptive statistics to test hypotheses. You cannot use descriptive statistics to test hypotheses. Because your hypothesis is there is a significant. What does the word significant means here? Significant, think about it in this way. I give you the simple thing. I made a sample of 250 and I just take the mean of their CGPA and I compare them and I say the average CGPA of female students in CAFSUR is higher than male students. Now you make a sample of 250 students. You make a sample of 250 students. When you make a sample of 250 students, maybe it is possible for you, because the sample is different. When you take the mean, maybe the mean of female students and male students become equal. Or the average of male students become higher than the female students. Is it possible? Is this possible? I am asking you, is this possible? If you make a sample from 800 students, I selected 250 students. Maybe you will select more male students and less female students, and then you will do, and maybe for you both are same. Then you will say, Mr. This hypothesis is wrong. It is false. It is not true. Are you getting my point? Do you agree with me, or do you have any confusion? I'm saying that if you make a sample and you test this hypothesis in the same way, maybe for your sample, the mean of male students was higher or equal to the female students, then you will say, Mr. This hypothesis is wrong, is false. You are saying it is true. Is it possible? Is it possible? It is possible. So according to me, I took a sample of 250. You also took a sample of 250. But the average can be different. Maybe these are other 250 students. Different students are there in the sample. So maybe possible that you test this hypothesis and your mean is not same. You will say this hypothesis is false. Mr. You are saying the hypothesis is true. Is it a possibility? Yes. Do you get my point? This is possible, right? Is this possible? Yes or no? I'm saying I tested this hypothesis that female students have higher CGPA than male students, or what Sama Said said, there is a significant difference between the male and female students' CGPA. How did I test it? I tested it by taking the CGPA. In my sample, there were 250 students, 200 females, 50 males. I took the average of female students. The CGPA average was 2.5. And for the male students, the average was 2.3. Based on this, I would say this hypothesis is true. I am saying this is wrong. I did not test this hypothesis. You cannot test hypothesis based on descriptive statistics. Descriptive statistics means mean, median, mode. I told you about it before in today's lecture. So I cannot use mean, median, mode to test the hypothesis, whether this hypothesis is true or false. And I give you the reason. The reason is you make a sample of 250 students in the castle, and then you take the average of their CGPA. Maybe for you, the average is same, or male students have higher CGPA than female students. That means then you will tell me that, Mr. Your hypothesis is false and you are saying it is true. So hypothesis is not conclusive in this case. Yes. Why? Because I am not testing it properly. This is not the way to test this hypothesis. Because I told you the rule. The rule is you cannot use descriptive statistics to test hypotheses. So I must use some inferential statistics. See the slide. There are two types. Where is the slide? Yeah. Descriptive, now you know. The other type is inferential statistics. Inferential statistics means, simply speaking, t-test. Do you remember t-test? T-test was similar to your normal distribution test. And what is the difference? In normal distribution, you can use normal distribution test if your n is very high. That means sample size is very high, like 5,000, 6,000, 10,000, which is not possible. So most of the softwares, they test hypotheses using different type of t-tests. T-tests are known as, or types of t-tests are known as inferential statistics. Simply speaking, if you want to test hypotheses, you need to go for inferential statistics. You cannot test your hypothesis through descriptive statistics. So what I have done before is wrong. Because my result is by chance. By chance, female student's CGPA was higher than male student. It was not a significant result. Because if you make a sample, maybe your result is different. So what I need to do, I need to test it through some t-testing or inferential statistics. Then what my result will come, if hypothesis is true, I will say with 95% confidence interval. Now, what is 95% confidence interval? 95% confidence interval means 95% of the time, if I say my hypothesis is true, after t-testing, not after comparing the mean. So it is not the right way. Descriptive statistics cannot be used to test hypothesis, because I told you maybe the result is by chance. Result is by chance. So I will test this hypothesis through some t-test, and after that I will say this hypothesis is true or false. Now this result will hold for 95% of the time. That means you do it 100 times, 95% of the time my hypothesis, what result I have said, will be there, which will be applicable. Only 5% of the time the error would be there. Simply speaking, you cannot use descriptive statistics to test hypotheses. If you have hypotheses in your research, you will always use inferential statistics. Descriptive statistics are only there to describe the variables like demographic variables, like age, gender, income, things like that. You never make hypotheses for the demographic variables. You always make hypotheses based on other variables like dependent or independent variables, or when there is an association. That means if I am doing some descriptive research, I will never make hypotheses, because descriptive research will never have hypotheses. You cannot test hypotheses by descriptive statistics. Please tell me if you understand this point. I have seen, first I want your clarity, then I will let you know. Please clear your mind about this. This is a very important point for your future research. That means I have seen many papers, many research papers in which they will write a hypothesis and they will just compare the mean or median or mode like thing, and they will say the hypothesis is true or false. No, you cannot do it. You have to test it through some inferential statistics in order to say that it is a significant result. Significant result means 95% of the time it will be true. This is not by chance. I hope my point makes a sense and you can link it. Is this point clear? The inferential use this in inferential statistics, Sama said, if you have some demographic variable, then that demographic variable would be affecting some dependent variable if you want to make a hypothesis of it. But if you are just saying the age, the average age of male students and female students is 15 or 16 years, then this is just a descriptive statistic. In many research, you will not find that some demographic variable is affecting the other variable, but it is possible in some research that this demographic variable affects something. Then you can make a hypothesis, but still you will test it through some inferential statistics. That means some t-test. You cannot use just mean, median, mode to show that relationship or show that hypothesis. Do you get my point? So hypothesis means inferential statistics. You cannot just describe this and you cannot just find the mean, median, mode and compare it and say that this is happening. This may be because of some, by chance this can happen. Is it clear to other students as well? Do you get the point? Please, yeah. So do not make this mistake in future. Muhammad Said, is it okay? And Hamid Jalal.
Mr. Descriptive, it's mean to.
Yes, Hamid.
Because I'm confused a little bit, Mr. Here.
Yeah. You can clear your confusion. You are confused about what? What is your specific?
Can you, Mr. repeat what is different between descriptive and inferential? What's mean this?
Okay. Descriptive statistics are only to describe something. At the start, what I did, I show you mean, median, mode. I was just describing it. Okay, the mean age of this class is 15 years. The median in this class is 16 years. Okay, so these are what? These are descriptive statistics. They do not test hypotheses. They do not tell you whether this is better and this is not better. This is just a description, nothing more. So descriptive statistics normally we use for demographic variables like age. So what is the average age? What is the average income? What is the, how many people live in city? How many people live in villages? Things like that. So what are you doing? In your demographics, you normally describe something. So what type of statistics you are using there? You are using descriptive statistics like mean, median, mode, range, variation, variance, or standard deviation, things like that. But when you have some hypothesis with you, when will you have hypothesis? When you are trying to show some variable affects some other variable. Or there is a relationship between this variable and the other variable, you will make hypothesis. Like what I did. I made a hypothesis like the average CGPA of female students is higher than male students in CAS source. And Samasai actually made it better. The correct wording should be, there is a significant difference between the CGPAs of female students and male students. Okay. Now I ask you that if I just simply take the mean of female student CGPA and male student CGPA in my sample, and I compare them, can I say this hypothesis is true or false? I cannot say that. I told you the reason. The reason is you make a sample from the same college. Maybe you will say my hypothesis is false. I am saying it is true. It is possible because mean or median or mode, these are not inferential statistics. Inferential statistics means you need to test it on 95% confidence interval. So such type of tests are called like t-tests. You don't need to, in this course, I'm not going to teach you mathematics. Software will do it directly, but I'm just telling you the logic. So if I want to test a hypothesis, I have to select some type of t-test. And that t-test will perform and check at 95% confidence interval, whether this is true or not. Then you can say something about your hypothesis, that your hypothesis is true or false, because that is why we use the word significant. Simply speaking, if you have hypothesis in your research, hypothesis means effect of some variable on other or relationship of variables. If you have hypothesis, hypothesis should only be tested by inferential statistics like t-test. You cannot test them by descriptive statistics like mean, median, mode, or standard deviation or variation. Is it clear now, Hamid Jalal?
Yes, Mr. Thank you.
So just put this in your mind. If you have hypothesis, you cannot use mean, median, mode, or standard deviation to tell that this hypothesis is true or false. You need to perform some inferential statistics like t-test. Okay, so SPSS is a software which is commonly used for, this software has both capabilities. It can give you descriptive statistics like mean, median, mode, or graphs as well. And it can also test your hypothesis. It can also test your hypothesis. So it has t-tests, different type of t-tests in it as well. So SPSS. SPSS means statistical package. You don't need to remember it. I'm just telling you what is SPSS abbreviation for. Statistical package for social sciences. But it is also used by physical scientists and biotechnicians as well, if they are doing some research in which they collect quantitative data through some surveys or through some questionnaires. This is the commonly used software in the world, SPSS. It is as easy as Excel. Okay. It is as easy as Excel. Inshallah, in next week, I will take one questionnaire and I will tell you how to input the data on SPSS. Okay, it's very easy like Excel. Very easy. Same like Excel. Okay, and how can you get descriptive statistics like mean, median, mode? And how can you get some inferential statistics if you want to test some hypothesis? So The t-test will also be available there. This is not the part of this course, but I will give you the basic understanding of SPSS as well for your future research so that you would know how to use it. Now the question is that how can you download SPSS? Uh, I have the copy with me here, but unfortunately it cannot be shared. What you can do, you can download the trial version of SPSS. In Google, simply write SPSS. The software download option will come. 30 days trial will be there, 30 days trial. After 30 days, you will not be able to use that software, but 30 days are good enough. So try to download that SPSS software so that when I will be doing it, you would know how to do it by yourself as well. I know that there are some courses in your specialization that uses SPSS because Dr. Senthil Raj and some other teachers, they also teach that to their students for their projects, final projects as well. In IT and communication, I'm sure. In IT and communication, I know that. Maybe in biotechnology, most of you are doing experiments, so maybe you will not collect some quantitative data. But in communication department and in IT department, there are students who are using that. Communication, for sure. For sure, in communication department, they are using. In some cases in IT, the final project is based on quantitative data, so they will be using SPSS as well. So it's a very common software. It's a very common software, very famous as well. So try to download it so that next time, inshallah, when I will input the data, you can do it by yourself as well. Otherwise, you will get the idea. Don't worry about it that you will not get the idea. But I wanted to tell you that SPSS has the capability of two things: descriptive as well as inferential. What is the difference between descriptive and inferential? I hope you know it now. And if in your research you have hypothesis, that means some research questions which will make some hypothesis, you will be going for some inferential statistics like t-test. You cannot test them through mean, median, or mode. Is it okay till now? Do you get my point?
Yes, Mr.
Yes. Is it okay? Hamid Jalal, you wanted to say something?
No, I mean, Mr. It's okay. Thank you.
Okay, okay. So just give me a minute and then I will take the next topic. Okay, okay. So this, please remember, this is very important. This is very important that you should know how to test the hypothesis. Uh, it's a very common mistake which is done by many researchers here, not students. Okay, there is one more important thing in this chapter, which is about like when you will be entering the data. First of all, you should know that you should change the data into numbers. You should change the data into numbers. Maybe you will have a question. What is your gender? Male, female. Now, male and female is not a number. These are strings or alphabets. Okay, so you have to change it into numbers. You can do this with software as well, but I think the best practice is that you will do it, you will change it by yourself. You will change it by yourself. Now, see that data, I'm just see the slides. Data is the set of observations or recorded values. There are different types of data which you should know. Nominal data, ordinal data, interval data, and ratio data. So there are 4 types of data which can be there in your questionnaire, in your survey. 4 types of data can be there. The first one is nominal data. What is a nominal data? Nominal means you would have some categories and not a number. For example, what is your gender? Male, female. What is your hair color? Either it is black, brown, gray, or some other color. Now, what I would tell you, I would always change it into numbers. So when I get the questionnaire, I am entering it in the software. I will give number, let's say male 1, female 2, black 1, brown 2, gray 3, others 4. These are the numbers which I have allocated. And in that SPSS software, I can give a label. I will show you that. Label means 1 is equal to male, 2 is equal to female. I can put that. But I will enter only numbers. Remember, computers only recognize numbers. They do not recognize alphabets like male, female. You know that. Many of you IT students would know that. The computer doesn't recognize what is written in English. It change it into numbers and then recognize it. Okay, so keep this in mind that it is better to change the nominal data. Nominal means categories, and change it into numbers. You can code it by yourself. Code it by yourself. It is up to you. You can code female as 1, male as 2. It's up to you. But you have to put it in the label. You have to put it in the label. When you will make a graph of it, computer will put the software, SPSS will take that label and it will tell you 1 male, how many are there in that graph or in pie chart. How many people with black hair will be there? It will take the label and it will tell you. It will attach it with that number and tell you. I will do that, inshallah. If you don't understand this point right now, it's okay. But you should know nominal data can be there in your questionnaire. Nominal data means categories like this. You can have nominal data. You need to change it into numbers. You need to code it into numbers. Is this clear? Nominal data. Is this clear? Okay. I ask you a question. Can I use nominal data for hypothesis testing? My answer is no. Because this is a data which is related to demographics or factual questions. What is your gender? What is the color of your hair? These are factual questions or demographics related to you or related to your surroundings. This is not your opinion or something like that. Okay, so nominal data will be, if you have nominal data in your questionnaire, totally nominal data, let's say, then you cannot test any hypothesis. You can just use descriptive statistics. That means the mean, median, mode, you can find those things, but you cannot test any hypothesis. Nominal data is not for testing hypothesis. This is just to describe something. You will be using it. Mostly your demographic data is actually a nominal data. Demographic data. You live in a city or village. So city 1, village 2, I will code it like this, but it is still a nominal data. It cannot be used for hypothesis testing. Okay, moving forward. The second type is ordinal data or ordinal scale. This is your questions which are ranking questions. Ranking, remember ranking? Okay, put these drinks in order of preference. Which one you like most? Pepsi I like most, so I will put 1 on Pepsi, 2 on Coca-Cola, and 3 on Dew. Dew should be DEW. Okay. Your order in the race, whether you want prefer, which order you prefer. I want second 1, first 2, and third 3. So this is my ranking. That means in this you will tell what is first, second, or third. Such type of data is called ordinal data. And ordinal data is also like nominal data. It is used for descriptive statistics. You can just find descriptive in this. You cannot test hypotheses with ordinal data. You cannot test hypotheses with ordinal data as well. So nominal data, ordinal data. Nominal data is about categories. You need to change it into numbers. Same is the case with ordinal data. Ordinal data is about ranking. Ranking means you need to tell which one is number 1 for you, which one is number 2 for you, which one is number 3 for you. For both of these type of data, you can only give descriptive statistics. You cannot test hypotheses with these type of data. Is this clear? Or you have any confusion? So it's easy. If I have a questionnaire in which I have only questions which are on nominal scale, that means categories are there, or there are questions which are only about your ranking. Please rank these in order of your preference. That means my research is just a descriptive research. It is not testing any hypothesis. It is not testing any hypothesis. Is it clear? Okay. Hamid Jalal, do you get the idea about nominal data and
No, Mr. Because previous class I am not present.
but this is just I told right now. Nothing is coming from the previous class. Simply nominal data and ordinal data. Nominal data means categories like male, female, or color of your eyes, color of your hair, or what is your height, maybe like that, or even age group between from 25 to 30. From this is what nominal data. You will just code them into numbers. Whereas,
Mr. I know about ordinal data. It's about in order.
yeah, order
That's what you know.
ranking, yes.
Okay, okay.
Okay, so nominal, but you should keep it in mind that nominal data and ordinal data. If you have such type of questions in your questionnaire, only these type of questions are there, that means you cannot test your hypothesis because these questions are not for testing hypothesis. Is Muhammad Said there or no? Is it clear, Muhammad Said? And who else is there from whom I can
Mr. Can you go up for nominal data, please?
for nominal data? Okay, this one. Abdullah Saleh, is it okay? You are there. Muhammad Said is also there. Saeed Abdullah, if you have any issue, you can ask. Ahmad Abdullah, Ahmad Dr. Loremi is not in class. Oh, you have low service. But Do you get the difference between nominal data and ordinal data? Nominal data is all about categories like male, female, or things like that. You can code them into numbers like 1, 2. Of course, in software, it is better to put them in the form of numbers, and you can give a label that what is this. 1 means male or 2 means female. You can give that label. But ordinal data means ranking, your order of preference. One thing to be kept in mind is this: if you have only ordinal and nominal questions in your questionnaire, you cannot use statistical inferential statistics. You cannot test hypothesis if you have only these type of questions. So what type of questions should be there? Just a second. So what type of questions should be there which will be used for hypothesis testing? That is the third type. And these are your opinion questions, actually. Opinion questions, which are, and we call them, interval data. Interval data are used for the opinion questions. This type of data will be called interval data. Remember, Likert scale. Likert scale: strongly agree, agree, neutral, disagree, strongly disagree. Of course, you still have to tell strongly agree is 1, agree is 2, it's up to you. Neutral is 3, disagree is 4, and strongly disagree is 5. Yes. But the question will be an opinion question for which you will make this scale, Likert scale. And the data which you will get from it is called interval data. And this type of data is actually used for hypothesis testing. That means if you have hypothesis testing, your questionnaire should have lot of questions about Likert on Likert scale, agree, disagree kind of scenario, and lot of opinion questions will be there related to many variables. So this is the most important type of thing. Otherwise, if you have nominal data or ordinal data, I would think your questionnaire is all about descriptive research. But if you have questions on interval data, interval for which you will get interval data, that means it will be on strongly agree, disagree kind of a scenario. These type of questions will give you interval data, and interval data is used for hypothesis testing. See the question on the slide. Is there any question? You know that if there is promotion, I will try to buy that product on promotion. This is your opinion, whether you agree with it or whether you disagree with it. So these type of questions will be on Likert scale. So your questionnaire, if you are testing some hypothesis, there should be lot of questions which will give you interval data. In simple words, you will have questions, rating questions. Remember, rating questions will be there. Having an opinion and whether you agree or strongly agree or disagree or strongly disagree to it. Is this clear? Is this clear? That means interval data is the most important data if you are using some analytical model, and your questionnaire should have lot of rating questions. Rating questions, remember, strongly agree, disagree. Rating questions give you interval data. Is it okay? Okay, good. So that means if you have hypothesis in your research, your questionnaire or survey will have lot of rating questions. Lot of rating questions. Rating means strongly disagree kind of a scale will be there. Likert scale will be there in those questions. And question will be opinion question, of course. We call them rating questions. Rating question means opinion question plus Likert scale. Rating question means opinion question and Likert scale. Okay, good. The last type is, which is not very common. Actually, most of the time we do not use it on questionnaires. We do not. This is used for measurement of anything. Measurement of anything. That means the question will be like this: how many times do I prefer Coca-Cola over Pepsi? I would say 3 times. Or if you can reciprocate it, reciprocate means make the opposite of it. How many times you do not like Pepsi over Coca-Cola? I will say 1 by 3. 3. So if you make the reciprocal of it, it will become 1 by 3. So such type of questions are actually called the ratio question, ratio data. Ratio data is not commonly used. It is not very common. Sometimes, maybe it depends upon your research problem, that you may have some questions which are like this: how many times you like this thing over the other thing? And you can just change them into ratios. These type of questions are not common. So you must know about nominal data, ordinal data, and the interval data. Interval data is the most common if you are testing hypothesis. Nominal data and ordinal data, they are normally used for to get descriptive statistics like mean, median, mode about demographics or things like that. Okay, I will end the class here because today we had some concepts which are very important. Inshallah, in the next class, I will enter the data in SPSS so that you will get the feel of it and you will find it. It's easy, very easy. I can assure you that it's as simple as Excel. Okay, I will end the class here.